I'm sharing my screen. Is it in front of you?
Yes, sir.
Okay.
Yes, sir.
So splitting diagram or complex splitting or T diagram of splitting in H1 NMR. So in NMR you are getting signal that is a splitting like a doublet, triplet, doublet of doublet, and a doublet of quartet, or maybe another one. Okay, if adjacent environment is same, then you are getting splitting according to n+1 rule, correct? If adjacent are 3 hydrogen, then you will get how many peaks? 4. Okay, if you're having adjacent 5 protons having same environment, then you will get 5+1, that is 6 line. But adjacent proton, if they are having a different coupling constant, if they are having different coupling constant, then they not follow n+1 rule. Okay, that is your n+1 rule not be able to calculate that you are splitting if adjacent proton having different J value, and that is giving the number of lines as the unexpected. Okay, so let's start a first example. Find line splitting pattern or T diagram for given signal HB at 6 delta ppm on 400 megahertz machine. And if J coupling constant given, HAB is 16 hertz, J for AC is 12 hertz, and J for BC is 2 hertz. Okay. Now you have to find out for HB proton. What will be the signal for HB proton? Yes, splitting for HB proton. So HB is coupling with HA, correct?
16.
By 16 hertz, and HB is coupling with SC by 2 hertz. Means these are
2 hertz.
two adjacent, two proton, but these two proton having different coupling constant, or they are in different environment. So as I expected, it is having two adjacent, it give 3 line, but not, it is not possible for HB. It gives the signal doublet of doublet. It is giving doublet for A and doublet of C. So your splitting will get doublet of doublet DD, and you're getting 4 line. Okay, so let's look how this T diagram will form. Okay, so splitting pattern for HB is asked. Okay, so from above, so HB proton shows DD, so doublet for 16 hertz and doublet for 2 hertz, correct? Because J A B is a 16 hertz, J B C 2 hertz. So in this T diagram, larger coupling constant split first. Those who having larger coupling constant, that is who having larger hertz, larger hertz is split first, or they are going to split first because they require lesser the that machine magnetic field. Okay. So let's start with this. If this line is of HB, okay, listen carefully. HB delta, yes, how much delta for HB? Yes, for HB, how much delta?
6 delta.
6 delta. Yes, okay. Let us say this HB is going to split. Okay, so we are making T diagram. So HB going to split, and it is giving signal. Yes, which it is giving signal doublet of doublet with 16 and 2 hertz. So out of 16 and 2 hertz, which is a larger coupling constant?
आवाज ब्रेक हो रहा सर, आपका आवाज क्लियर नहीं आ रहा.
So out of this two coupling constant, 16 and 2 hertz, which is a larger coupling constant?
16 hertz.
16 hertz, and smaller is 2 hertz. So this HB gives doublet of doublet. That means this HB line will split into doublet. Doublet means how many lines? Yes,
2 lines.
2 lines. So that line of HB split into two line. Okay, it is shown like this. So it is doublet and it is giving two line. Yes, is it in your screen? Yes.
Yes, sir.
Okay, so that is a doublet, and that gap between or distance between two peak is a 16 hertz. So that is called as the coupling constant. What is coupling constant? The distance between two peak is a coupling constant. So this is having 16 hertz, correct? Now you are getting doublet, and that two line again split. That two line again going to split into doublet because your signal is doublet of doublet. So another signal, this line splitted with doublet with how many hertz? So remaining 2 hertz. So
16
that
hours.
two line now
2.
further split. That is like a tree we are making. That one branch, that branch giving more branches like this. So here it is also making branches. So this is giving two branches. This doublet, two lines means two doublet. So this is making two line here. Yes. And what is the distance between these two peak? Yes. In hertz.
towards
Yes. So this is a 2 hertz distance because it is splitted due to that second geminal, that is the 2 hertz. So distance between them is 2 hertz. So that is the 2 hertz. Now you're getting that signal, that is doublet of doublet.
Yes.
Okay, so you're getting four line like this, and actual signal is like this. Okay. So this is doublet of doublet. So first HB is splitted into two lines by 16. So gap between them is 16 hertz. And once they are splitting, they are further splitted into doublet because of second coupling constant. And that second coupling constant is 2 hertz. Therefore, this 16 hertz two line further goes to split into two line by 2 hertz. So you're getting four lines. So your signal is a doublet of doublet, and actual signal is looking like this. Okay, this is the doublet and this is a doublet. Okay, but they are having of one proton signal, that is the HB signal, doublet of doublet. Okay, and this has happened due to different coupling constant. Okay, if coupling constant is different, you are getting such four line. Is that clear? Yes.
Yes, sir.
Or any doubt, or want to repeat it?
No, sir.
Okay. Now this line value for this four line, you are getting doublet of doublet. How many lines you are getting? Yes,
4 lines.
four lines. So what will be the value of that four line in delta or in hertz? You have to calculate, or sometime it is asked to calculate hertz, value of hertz. Okay, so here,
Hmm.
those who are playing with screen by pen, please stop it. Okay. So next you have to calculate the line of that. So this is your splitting of HB. So hertz value from that delta ppm can be calculated, or can be using that formula. So delta ppm is equal to V frequency in hertz divided by spectrometer frequency in megahertz. Directly you can calculate. Therefore, that hertz value become this frequency in hertz is equal to delta into machine frequency. Or one can use this formula also. Chemical shift delta ppm is equal to shift from tms in hertz divided by spectrometer frequency in megahertz into 10 raised to minus 6. To convert this megahertz into hertz, it is become 10 raised to 6. So this 10 raised to 6, 10 raised to 6 be cancel, and therefore shift from TMS in hertz is equal to chemical shift delta into spectrometer frequency. That is a multiplication takes place. So delta given in a problem. Yes.
Yes, sir.
Yes. What is the
Yes.
value of delta?
6
6
ppm.
ppm.
6 ppm, and machine frequency
400 megahertz.
400 megahertz. So what will be the value in hertz? That peak value in hertz? So 6 into, that is delta into machine frequency. So 6 into machine frequency,
2400
6 into
hertz.
400, that is a 24 hertz. So this first line is off due to 64 200 sorry that 2400 megahertz. Okay, so this HB is equal to how much hertz? Yes,
2400 hertz.
24, yes, hertz, correct. Now this HB is splitting into two line of how many hertz? This HB is splitting into 16 hertz. Okay, and that HB is a middle for this two lines. HB is exact median or middle of that 16 hertz. So what is the value of left hand side and what is the value of right hand side? Yes,
1200 hertz each.
yes, value in hertz. So
1200
that
hertz each.
this is 1200. No, it is 16 hertz. So 16 hertz means this middle having 8 hertz on right hand side and 8 hertz on left hand side. Okay, so exact middle.
Okay.
So from this middle it is 8 hertz and exact middle from it is 8 hertz. So middle is how much?
16 hertz.
2400.
No, we will minus 8 on one side, add 8 on the other
Yeah,
side.
so minus for left hand side and increase on right hand side, because your delta going to increase on left hand side. Right to left, delta going to increase. Correct? Okay.
Yes, sir.
So on left hand side it become 2408 2408. 8 is going to add here and 8 is going to minus from that. So it become 2392 and 2408.
0.
Are you getting this?
Hertz.
Yes?
Yes.
Yes, sir.
Okay. So this middle and your J is equal to 16 hertz. So for left hand, you have to add 8 hertz, and for right hand, you have to minus that 8 hertz, half of that J. Okay. Now this again is splitting into doublet with 2 hertz, correct?
Yeah.
This 16 hertz doublet is splitting to 2 hertz again. So what is the value of extreme left? This left line value?
2410.
Yes,
2410.
2409,
2409.
because this is a median. This is a median, and you have to add 1 here and 1 there, correct?
Yes,
Yeah.
sir.
1 is going to this 1 hertz and 1 is going to this. So value for left is 2409.
2409.
And what is its partner line? This line is
2407.
2407. So
2407.
2407 and this is 2409. Difference between them must be 2 hertz, correct?
Yeah.
Okay. Now in this second right hand 16 hertz peak again splitted into 2 hertz. So what is the value on extreme right? This value?
2391.
Yes, 2391, because 2 hertz, half going to here, half is going to there. So it is 2391, and this line one is
2393.
2393, correct. 1 hertz you have to add to go on left hand side. So that value become 2409, 2407, 2393 and 2391. So that is the hertz value of that line. So such question also asked in paper or in second year, it is asked many times, and now it is in your syllabus. So maybe there is chances to ask like this question. Okay. And what about their delta value? Yes. Hello. Hello. So their delta value, just divided this hertz value by machine frequency. Your machine frequency is
400.
400. So just divide that machine frequency, you will get delta ppm. That is a shift from TMS in hertz divided by machine frequency. That the 10 raised to 6 cancel, this is getting cancelled. So you're getting delta directly. So by dividing them to 400 machine frequency, you will get this line in delta ppm. So line will be at 6.0225, 6.0175, 5.9825, and 5.775. And center of that lines, they say doublet of doublet. Center, where is the center of that 4 line?
6. 6.
Yes, so it is a 6, or it is your starting 2400 hertz. So your peak at 6 hertz, but you are getting 4 line. This 4 line you are getting at 5.9975, 5.9825, 6.0175, and 6.0225. That is your signal lines. So are you getting this?
Yes, sir.
Yes,
Yes.
sir.
Any problem? So how to draw splitting pattern and line value? Okay. Sometimes this line value given and you are asking what is the coupling constant between them. If you giving this hertz value, 4 lines are given. What is the coupling constant? So just minus both
Subtract.
value. Okay,
That's
subtract it. So that is 2409 minus 2407. You're getting 2 hertz, correct? And these 2 lines, okay, this 2 line also gives 2 hertz, but middle 2 line not gives any that coupling constant. Then check out 1 3 line, okay, check out that 1 3. What is a J?
1 3 line.
1 3 line,
16 hertz.
16 hertz. So that is, and there's 2 4th line, 2 4th line
16
also
hertz.
getting 16 hertz. So your coupling constant is 16 hertz and 2 hertz. Repeatedly we'll get the J value for 2 times, okay? So that is your J. If you're getting 1 time, that is not your J value. You have to get, if 4 line, you have to get similar way 2 times or more than that. That is your J value, okay? So is that clear? Or any problem in this?
No.
Okay, next question. So you are asking HC proton. SC proton having again same. So splitting proton for SC. So SC shows a signal. SC shows signal at a doublet of doublet with J is equal to 16 hertz and 12 hertz. Yes, correct. So SC with it is
Sir,
12 hertz and 2 hertz.
sir,
HP.
16. Sir, 16.
Okay. For SC, it is giving doublet of doublet with 12 hertz and 2 hertz. Yes. So
Yes,
it
sir.
is not 16,
16
it is
hertz or not?
12 and 2 hertz here.
Hmm.
So here 12 and 2 hertz. So its T diagram is like previous one, correct? Only instead of 16, it is how much? 12 hertz. So
12 hertz.
okay, so first splitting takes place.
First splitting to 2.
But how much hertz? That is a 12 hertz with A.
12
So it is a 12 hertz. So it is shown like a 16. It is a 12 hertz. Okay, that is copy pasted here. It is a 12 hertz, correct?
Yes.
Then again it is splitted Again, it
They're
is
in 2 hertz.
split into two lines. That is the doublet of doublet. And what is the J between them? Yes,
2 hertz.
that arrow showing 2 hertz, correct? So here I think it is written 12. So instead of 12, it is a 2 hertz. So this is 2 hertz, and it is also 2 hertz. Yes, and you're getting again 4 line like previous. Okay, and this lines look like this one. Okay, so you're getting 12 hertz for splitting and 2 hertz second splitting, because it is a doublet of doublet at 12 and 2 hertz. So, yeah. And what about HA proton? Okay,
HA 16 and 12.
yes,
16 hertz and 12 hertz.
okay. Actually, the distribution here is a mistake. Actually, this is for HA proton. Yes, now by consider this is a HA proton. Okay, so HA proton, this is a HA proton. Now consider. So HA proton gives, that is not
16 hertz.
SC. So it is a HA proton. So it gives 16 and 12 hertz, correct?
12 hertz.
Okay. Now for splitting text plate, which is a larger coupling constant, that split first. So actually mistake in this H, not a HC, it is a HA. So this is HA, and that HA first splitting takes place at 16 hertz. Yes, so 16 hertz for splitting, you're getting doublet with 16 hertz, and then you're getting doublet with how many hertz next? It is
12 hertz.
12 hertz. So it is a 12 hertz splitting. So you're getting 4 line for HA. It is getting 4 line like this. Yes. And your peak will be appear like this, 16 and 12 hertz like this. You can calculate their line value. So one can calculate line value if machine frequency and delta value of that particular proton is given, then one can calculate J value, value of each line. Okay, any question in this?
No, sir.
Okay, so we are moving next fastly. It is a, as a reference, that is a analysis of vinyl acetate or splitting pattern in vinyl acetate. So as previously we discussed, like that's such a pattern. If it is AR, we discuss here, and here acetate is given. So here J trans, we know that coupling constant for trans is higher, and then the it is greater than J cis having 12, 10 to 12, and then J minal having 1 to 2 hertz. So that splitting are given. You can make its a tree diagram by taking their J value. Okay, so you can calculate their J value, line value of each. So that is for your homework. Just look at, already we discussed all three of them. Next pattern, here find out the line splitting pattern or T diagram for HB proton. So HB is given here, and JAB is a 12 hertz, that is they are cis, and JB to CS3 is a 6 hertz. Yes. So HB gives with signal, HB gives,
12 hertz.
so HB coupled with HA giving doublet, and HB coupled with this CS3 giving, for CS3 HB gives
Singlet.
singlet. Yeah, so singlet. No, it is not singlet.
No, sir.
So
Quartet.
quartet.
It is
Quartet.
quartet. So that HB gives doublet of quartet here. Am I correct? HB gives a doublet of quartet because one HA with 12 hertz and with 6 hertz on that CS3. So coupling constant are different. So it gives doublet of quartets. And how it's split, let's look. So first line of doublet that so HB shows a doublet of quartet with J is equal to 12 and 16 hertz. So this is HB, your HB line you have to draw first. First it splitted as a doublet or quartet. Yes,
It's doublet.
it is splitting as a doublet. Why doublet?
Higher coupling constant value.
So that doublet having higher coupling constant and higher coupling constant split first and then lower because of that machine frequency that higher the coupling required less energy that it. So here it's splitted by J is equal to 12 head. Again you are getting how many lines for doublet? Yes,
Yes.
two lines. So this
lines.
is 2 line for doublet and that 2 lines now further splitted into how many lines?
4.
Yes, so this is a 12 hour. So this 2 lines is going to split into 4 line or each doublet line is going to split in 4 line.
So each doublet will split into
Each
4.
doublet.
So each
So total
line,
eight
yes,
lines.
okay, each line now splitted into 4 because you are making tree. So tree branching is there. So each line is going to split as a quartet as like this. So this is a further splitting. Yes, is there 8 lines in this tree diagram?
Yes.
Yes.
Okay, 8 line and this 8 line. So distance between this peak are this middle one. How much distance or value of that arrow? It
6
is
hertz.
3 hertz or 6 hertz
3,
or 2 hertz.
3 hertz.
6.
Yes,
Mm.
it is 2 hertz,
6
3 hertz
Two,
or
sir.
6
2,
hertz.
Two,
Yes,
2, 2, 2.
it
2
is
each.
two, two.
so it is not
Oh, sir, 1.5.
not a 155. This line is
2, 2.
having
Two, sir.
6 hertz because they are splitting by 6 hertz. So each line difference is 6 hertz, not 2, not 3, not 1.5. Okay, so this each line is having distance of 6 hertz. Yes, are you getting this?
Yes.
Yes, so each line is having distance 6 hertz. So that is the splitting 6 hertz, 6 hertz, 6 hertz. So what is coupling constant? The difference between 2 lines. So here it must be 6 hertz. Difference between 2 lines is a 6 hertz each. Are you getting this point?
Yes, sir.
So each line having 6 hertz splitting. Okay, and this actually peak look like. Yes. So this is you are getting. What is the intensity of quartet? The intensity of quartet line intensity you might be studied as a Pascal triangle. Yes,
Mm.
Pascal triangle intensity for singlet 1, doublet 1:1. For triplet,
1:3:3.
so for quartet is a 1:3:3:1. So this line is 1, this is 3:3:1. It is also 1:3:3:1, and this is doublet having equal intensity. So this blue is shown actual peak observed like this in NMR. Okay, so this is the actual NMR peak. Yes, and this is how many lines? Let's count. This short is 1, 2, 3, 4. So this is 4 line. This also 1, this 2, 3, 4. So 4 line, and this two whole quartet. This two whole quartet is nothing but doublet. Okay, these two quartet are doublet, and that doublet is splitting into 4 line. Yes,
Yes.
that is your two hand, and this two hand having four fingers. That is the doublet of quartet. That is a tree diagram for this. Okay, so question may ask on this like this. So what is the splitting pattern and line intensity and line value of given proton HB? Now if it is given uh, that value is 6 hertz, 6 delta, then what is the line intensity? Okay. If HB is equal to 6 delta on 400 megahertz, so what will be the line value? Can you calculate?
Yes, sir.
0.
Yes. Okay, calculate on
Yes.
page. Time is over here. We are starting new meeting. 2-3 problems are there. Then that splitting
Mhm.
pattern will over. Okay, just calculate in 5 minutes. Yes. And
Yes, sir.
in new meeting, I can ask to you what is the value for this. Yes.
Mhm.
Okay. So we ended here meeting, and we're going to start new meeting. So